All right, let's go over this question we did in class here. You'll never have as many friends in your life as you do in high school. A statistician decides to test the accuracy of the statement, so he conducts a long-range study. He starts with 1,000 high school seniors and asks them to count how many friends they have. Every year, for 25 years, he stays in touch with the students via email and asks them to inform how many friends they have. The statistician averages the number of friends per year and 25 years later plots the points age as your x, let's write that, age as x, nope, don't want a highlighter, and y is the friends. The least squares regression line is the predicted of friends, that's what the hat is right there, is equal to negative 2.94 times age plus 116.14, and the computer output gives us r squared equals 0.58. So question number 1, what is the direction of the association? The direction comes from your slope. And if you think about this, let me write a super easy equation here. Or your calculator uses ax plus b or something like that. So it is this one right here, which is what? Positive or negative? It is negative. Okay, question number 2. The strength of the correlation. The strength comes from the r value. So if r squared equals 0.58, and you take the square root of both sides, you will get an r value to be 0.76. Now, the strength and direction, the direction is negative because that comes from the previous problem. So you have an r value that's negative 0.76. Is this strength very strong, moderate, or moderately strong or moderately weak? Okay, I would say that this is moderately strong. What are my descriptions for that? I would say 0.8 to 1, positive or negative. That's less than, right? So maybe to 0.4 to 0.8, not including 0.8, and then 0 to about 0.3. Okay? All right. Number 3. How can you interpret the equation? So, see if I can get rid of this. This problem here is talking about the slope. How do I know that? It's using the word for every. Okay, so let's just interpret slope. If I go up here. And slope is negative 2.94. It is the change of y over the change of x. That's what slope is, slope. Okay, so the change in y is your number of friends. So if you look at our multiple choice, it has for every friend, or every, it's kind of weird, but you say one friend. So that would be 1. And then the x value is what happens for your this. So y represents the your age. That is wrong. So let's switch those. So x represents age. So for every 1 year, the number of friends changes by negative 2.94, which you round, which is 3. But remember, it's negative, so that means you basically lose 3 friends per year, basically. Okay, question number 4. what is the correct interpretation? This problem, let's move a different color, is referring to the coefficient of try the orange again. This is referring to the one here, which is called the coefficient of determination. And basically, this is going to help us determine if we should use a linear squares regression line. And if you change 0.58 by multiplying it by 100, you move it 2 decimal places, you get 58%. Okay, and so the correct answer is B. No, sorry, C. "58% of the variation in the number of friends can be explained by the linear relationship of age on friends." So, the number of friends, if we did that sentence frame, this was the kind of like y, can be explained by the LSRL of x on y. Okay, so that is number 4. It's not awesome, the least squares regression line. It's not great. It's not good. It's okay. 60% is okay. It's kind of iffy, and it's not bad. It's not super bad, or I wouldn't use it, but it's okay. Okay, let's do D. A 20-year-old is predicted to have what? Well, 20 is an age, so this is my x value. X equals 20. So if I use that formula above, y hat equals negative 2.94 times 20 plus 116.14. PEMDAS, negative 2.94 times 20 plus 116.14. This would give you an answer of B, 57 friends. Okay, and let's do our last one here. A 30-year-old in the study has on average 25 friends. What is the residual to the nearest predicted? Okay, so the first thing we're going to do in this one is get a predicted. To get a predicted, remember, x here is our 30-year-olds. That was what my variable represented, okay? And then they're saying the actual, so let's say y hat, I'm using the formula above, negative 2.94 times now 30 plus 116.14. What I get is y hat equals 27.94. Okay, and then the second thing I'm going to do is now I'm going to figure out the residual. Remember, this is a regular, but everyone should take a AP exam. So AP, actual minus the predicted, or observed minus the predicted. So the actual in this problem was the 25. So 25 minus the predicted, which we had over here in yellow, 27.94, which gives us a residual of a negative, approximately negative 3. So our choice would be B. So our predicted had 27.94 friends, but then our actual was 25. So our least squares regression line was too high, which means the predicted was -3 or lower than the least squares regression line. So hope that was helpful for you guys going to this problem. See you guys.